And that's basically including all the cool toys. Like Philip also has only, I mean, it's, of course, they must serve the purpose, but we always try to make them also nice. So the electronic control system includes hand units, motor controllers, lens motors, also one lens data encoder, maybe you know it, distance measurement, and also somehow the Arri lens data system. And I will talk about all this kind of stuff. And I'm very happy if you cannot interrupt me if you have a question. You can ask me also later. We have all this stuff here for playing, hands-on. And I'm sure some of you already work with it, right? Can I know who already maybe had the WCO4 in a sense, working with it? Not yet? Okay, yeah. And I'm very happy, like Philip, also to get feedback, because that's really what we need to improve. We always make new software updates, new functions, new hardware tools. But I walk you through from the beginning to the end. So I start with the Alexa system. The Alexa system is over there. It's not the official name, but it's using the Alexa, so it's our Alexa system. And as you see, it has some integrated motor controllers, so it's quite compact. You don't need an extra box and so on. You can access the camera with your handset directly, plug your motors there, drive your motors, control it from a distance. Then when the Alexa Mini came, we also integrated the radio module into the Alexa Mini. And the Alexa Mini was so small, really the target for the Alexa Mini was to really have a real small and lightweight camera so that you can put it on drones and gimbals and so on. And that small space required really to have some ideas about the connectors, and we didn't have space for focus, iris, and zoom connectors. So we used that new and old idea of daisy chaining motors. Maybe some of you know the CLM1 motor. We already had some daisy chain motors. Now we did that again. We have a cooperation with C-Motion. You know, C-Motion is also a company in Vienna doing such systems. They have a common history with Arri. So after 10 years of being like competitors, we decided it doesn't make sense to have Arri Austria developing this stuff in Vienna and C-Motion developing this stuff in Vienna. Let's cooperate, let's bring nice products faster to the market. So one result of this is the C-Force mini motor that is such daisy chain motors. You see you have one connector on the mount and you can daisy chain up to 3 motors, but even other equipment. If you look at the Mini here, we have 5 devices, not only the 3 motors, but another one here and another one here, all daisy chained to this one connector. So you can really do many things with it. Very compact system. The Alexa Mini system. Then we have the universal system, which is basically, it's an Alexa Plus module, more or less, but taken out of the camera and make available to put on any other camera. So it's basically the Alexa Plus module, and that's a device that really does most of the things of our devices. There's very many connectors, as you see. It's maybe not the smallest, but it can do many things. I'll talk about that later. That's just to give you a small overview about the things we have. So that are the 3-channel systems, the bigger systems. Then we have some small, lightweight systems. One thing I forgot. All of the 3 things I showed you just now, so Alexa Mini system, Alexa system, and the universal system with the UMC4. If you combine the UMC4 with Amira, for example, you can also control camera settings with it. Very useful with the Mini if you are having it on a drone or somewhere, want to put an ND filter or remove internal ND filter, you can do that remotely through the handset. Also frame rate, shutter angle, exposure index, and so on. And then we have the small motor controllers or receivers, or however you like to call them. Sorry, I'm standing in front of, you have to say something. If I make something wrong, I'm standing in front of the monitor, I look at mine, and you don't see anything. So we have the small one, the SMC1, single channel system. That's really designed to drive one CLM motor. Very basic thing, just drives the motor, not much more. perfect combination with our small single-axis unit. Our customer gave it the nickname the sexy unit, maybe because of the wooden hand grip. Here you see it, combination, very simple system. Some Steadicam operators like it. It's not too expensive, but also does just the basics. Then we have the servo zoom system. We have it over here. Battery just went empty. It can drive a servo zoom directly. So you have that small box on your camera, connected with one cable from the lens, connected to a power source, and that's all. And then if you also have a battery, a full battery, you will see that you will also get the lens data on the handset instantly, because their servo zoom lenses, they are quite intelligent lenses from the broadcast world. They provide lens data, because in the broadcast world they use lens data since quite a while, and that's instantly displayed, and you get your focus iris zoom information. You can control that from here. Of course, there are some limitations, because it's sometimes not the fastest motor in the servo, but you can do it. It's very lightweight, very simple, plug and play. And then last but not least, we have we call it the universal light system. It's universal, drives up to 3 motors, but it's lightweight, and also functionality-wise, it's quite light. It doesn't do lens data and so on. It's just driving 3 motors. You can daisy chain them, same concept like with Alexa Mini. We also have it over there. And that's basically the 6th motor controller we have. So we have the 2 integrated in our cameras, Alexa Plus, Alexa Mini, the big universal one, the smaller universal one, the ENG one, and the single channel one. All right, so that's what we got, what we have, and of course we always, and that's what Philip said, we always try to make new products that help you. And we listened to you and your colleagues, and we saw that with the Mini, the concept, with the Mini, and I come to new products now, was really to use it on gimbals and so on. With the CFOS Mini, perfect combination. But more and more we saw setups like this, for example, with a big zoom. Cannot really move it very fast. With the CFOS Mini sometimes there are some limitations, or maybe that you need more torque, So for that reason, we brought the CFOS Plus motor just at NAB in April this year. Looks like this, and it's a bit bigger than the Mini, but it also has more torque. And it's fast, The CFOS Mini drives around, I think, 150 teeth per second, and that is 180. Has a bigger gear also, so it's faster and has a considerable torque. It's really always a thing with the motors to get the right match between speed and force. But we think that with this motor you can even work with it under some conditions where other motors maybe have some limitations. Of course, we still have the CLM3 motor, which is really like a monster a bit. It's very strong, very fast, but also a bit heavy. But the CFOS Plus is serving most purpose. Also, if you have a lens in a cold condition, maybe in Spain not always the case, but in cold countries can happen really. And then if you have a small motor, that when the oil in the lens, the grease in the lens became hard, and you cannot really move the motor anymore.
Can you see the CFOS Plus has the same strength than the CLM4?
Actually, the design is quite similar, but it's a bit stronger. It's a bit stronger and faster, yeah. We always, that came later, and we always, with everything, we look for the latest and greatest. And we found some primary motor inside that is a bit more horsepower, so we took it, of course. Yeah. Oh, wrong direction. Then another question that we got many times, this setup. You see that we have the UDM1 there, and we get the readout on the display. And the question I got like 100 times in the last 6 months at least was, can I get the distance readout on the Mini? Because people also had it on the Plus. You know, with Alexa Plus, you can connect a CINE tape or UDM1 to the Alexa Plus, get the readout on the handset, quite convenient. Was not possible with the Mini, because the Mini also we had to economize on connectors and so on, and we didn't have that serial interface on the Alexa Mini. We had a CAN bus based interface, but not the serial interface like this requires. So it wasn't possible, but now we also made it possible, actually with the L-Cube CUB1. L-Cube is a family of products. It's small converters that convert other protocols to the L-bus protocol, which is our internal communication protocol. So this is a CUB1. Sometimes difficult to find abbreviations that are not yet used by other cables or products. So CUB1, that's like cube. Yeah? So CUB1, it's that little guy here. It's also over there on the Alexa Mini. It's a number 4 in our daisy chain setup over there. And that basically translates. So you have this 3 components. You have a UDM, could also be a CINE tape. You connect it here on top to the L-Cube and feed it into the daisy chain with the motors, and then you get the readout on your handset. So that's basically what it does right now. And as with all my products, it has software, which is why I have less hair here and much gray hair here. But that's a disadvantage, but the advantage is that it can do, it matures. It's still a baby. It comes a time when it's like grown up and it has all the functions. In between, it has a premature age. That's when all the bugs come up. But it's a joke. But that's how it is. So it does one thing now, and in future it will do much more things. Meaning, it could be an extension for L-bus cable. Yeah, if you can convert a L-bus signal to RS422 or whatever, and translate it back to L-bus and have a long distance, for example. So it does one thing right now, but it will do more in future, for sure. With the Alexa, the L-Cube, yes. With the C-Force motors, you mean? On the Alexa?
Yes. No, in the Alexa Mini, you need to connect first L-Cube and the serial connector, or is...
You mean this question?
Yes.
If you can do like this or like this?
Yes.
You can do any order, doesn't matter.
Okay.
Yeah, it's really this protocol that's it gives some like or I don't know how to translate, like some orders, and all the devices listen, no matter where in the chain they're sitting. They're listening. If their name is called, they do what they need to do. So you can put it wherever you want. Now in that case, I've put it directly behind the mount because it's just a cleaner setup, but it doesn't matter. So that's the L-Cube. Sometimes the small things are the nicest. Yeah. And now I come to lens data. Lens data is something I like to talk about. It's quite complicated. If you look at this number here, you see it's a lens. Actually, here's the time code. Then you have the lens name and the focal length and the focus iris zoom information. It's quite cool. But you know, many people, I was very scared of lens data in the beginning. And I was thinking exactly like this, lens data. Yeah? But don't be scared, because there are 4 benefits of lens data. Okay? And those ones are really important to remember. And if you remember them, then the small pain you have to go through now with me is forgotten very easily. So we have to do some theory now. First I have to explain to you what is lens data and how do you generate lens data, and then I will tell you the 4 benefits. So to generate lens data is data from a lens. It describes how is my lens set, my lens scale, and which lens am I using. It's all lens data. And to get that information, I need an encoder on the lens, an encoder that tells me the position of the lens ring. Yeah? Encoders usually give just like machine values. It could be output like 3561. And if I get that value, I don't know what it means. So I have to translate that for my lens. And I have to know that this number the encoder gives me means maybe 3 meter 60. So that's the second thing I need beside the encoder. I need a lens file. And that lens file is like a translation or like a lookup table for my encoder values. Those two things I need to get the lens data. I can get it with the LDS lens instantly. So if you have a master prime or LDS ultra prime or master anamorphic, for example, inside the lens is a magnetic encoder, magnetic strip and encoder reading the position of the lens ring. And then if you connect, and there's also a file inside the lens containing the lens lookup table, so to say, lens file. When you connect it to a Arri LDS camera, like Alexa Plus, Alexa Mini, then they like shake hands and say, hi, I'm the lens, so and the camera say, oh, nice, come in. And then the first thing the lens does is transferring the lens table to the camera. Because the camera has the horsepower to do calculations in real time. So now the file is inside the camera. When I turn the lens ring, these encoder values are transmitted very fast to the camera. And the camera does the calculation and saves them, for example, with every image. And the good thing about this, if the camera is recording images in any frame rate, the camera knows exactly when the image is recorded, and at that time it can take a lens information and also record it. It's very accurate, actually. There are other systems that do it externally, they're also accurate, but if you do it in the camera, it's a bit more accurate. Yeah? So that are the two things you need. The lookup table can sit in the LDS lens. If you have a ultra prime, for example, or compact prime, or some other lenses that Arri is selling, you will find that lens tables in the lens data archive in the camera. So if you go to Alexa Mini or Alexa Plus or also UMC4 motor controller, there's a menu, lens data archive, and there you can select your lens file. You have to take care if you have ultra prime, for example, I think most of you know that, there's a small letter on the focus barrel. It's like the focal length, and then under it is written NN or L or something like that. That's a scale class, because when you manufacture a lens, there are always some tolerances or some spreads, a different spread of the scale. So these different spreads are grouped into different scale classes from size. And then if you select the correct scale class, it's engraved on the lens, then you have the right spread on your focus scale, and then your lens data is matching with the scale. So you would go to the menu, select it, you have the lens file. There's no encoder in the lens, but the encoder is in the motor, so you also have this. So you can get the lens data as well. Because your lens motor is giving you the position of the lens ring, and the camera is having the lens file, and you get your lens data. Now if you have a third...
That works only with our motors?
Yeah, that's one of the reasons why we only support our motors. Okay. Because if we would support third-party motors, we probably wouldn't know which encoder is in there, or if we know it with one motor, the manufacturer might change it, another encoder or whatever, and then the lens data is wrong. So it's really some precise calculation, and we normalize some values, because even us, we're using different encoders. You can imagine the CLM2 is in the market, I think, now since 18 years, and we are still selling it. And the latest motor we brought out last April. So of course, there are different encoders, but we normalize them. We have some internal intelligence and software that do the calculation. But if we would support any third-party things, it would be difficult to really be accurate and to keep our promise that it works.
Sorry, the precision on the motors is as precise as the magnetic encoder on the lens?
Yeah, I mean, yes, it's actually, yeah, you can say that. Yeah, there's no difference in the lens. There's not that the lens is more precise or the motor is more precise. So now we can also do that with the Arri lenses. What happens if you have a third-party lens, like a Ingenieur zoom or a vintage Kova lens or whatever? You can use the encoder, of course, of your motor, but you don't have the lens file in the lens data archive, because Arri cannot know all the lenses in the world. So for that reason, you can program a lens file. It was possible in the past only through the Alexa camera or with the older system, also with computer and so on. Now it's also possible with the WC4 handset. That's the image you see there. So you select all the information. You can program in as many data points as you want. We had a version first where it was limited to 14 data points. We've opened it up to more than that. The more you take, the more precise it gets. And then you can program your lens file. You will save it on your SD card, and you will have it on your SD card. And whenever you get your lens again, you can take that file, load it in your camera, and get your lens data. And the advantage of it, you can really build up your own lens data archive. And if you get a lens again, you don't have to do it again. Or if you see that there's a change, maybe the lens went to service or some things are misaligned, you can edit the lens file. You don't have to do everything from zero. We're planning to, so at the moment you have to load it in with the SD card, and with the Alexa Mini currently it's a bit cumbersome because you have to do it with a USB stick, and you save on SD card, you have to put it to the USB stick and load it in. We are working on doing that wirelessly, so that really in future you can select through the handset and transmit it wirelessly. It takes some time. So now we also covered this, so you can basically get lens data really with any lens. And now you might wonder, why is he talking a half an hour about lens data? What's the benefit? And I told you there are 4 benefits. The first one is very obvious, is a lens data display. If you don't see the lens, it might be it's on the crane, it's under a rain cover, or it's a very small lens and you don't really see the scale anyway anymore because it may be so old. Then you see it at least on your handset. Might also be the situation if you have the WSU4 pulling focus. The DP has a sexy unit pulling iris. He's doing some changes. You see exactly where the iris is, t-stop, and the depth of field. You have it on your handset. That's the most simple and obvious benefit of the lens data display, of the lens data. Lens data display, number 1. Second one is lens mapping to pre-marked rings. I think it's, do some people work here like that? Or, yeah? Always, yeah. So that's I think the biggest benefit of it all, because you can map your lens, your focus scale to one of our pre-marked rings. So you can basically be completely independent from the lens. You can change lenses as long as you have the lens data from those lenses. You can keep that ring that has the best spread for you. So if you're shooting and you know, I don't need to come closer than 3.5, than 1 meter, 3.5 feet, for example. You can leave that ring there the whole day, change lenses, have your spread nicely from 1 to, I don't know, 8 meters. That's what you need in that scene. And change the ring if you just need a different spread, or if you need to get closer if you have a lens like that. But you're completely in this, 2 completely independent things. That of course can save, I think, a lot of time, huh? Or it gave you a good feeling to get used to the muscle memory.
How long do you adapt for your handset?
Your hand get used to it.
Yeah.
Of the difference.
Yeah.
So
Yeah.
you don't even have to look at it sometimes.
Yeah. So that's the lens mapping. Then we have a third thing, is focus tracking. And I put the slate there because now I've already said what I want. I should take another funny image, but people sometimes think, what is focus tracking good for? Focus tracking means you get your distance information from the UDM1 or for the CINE tape on your handset, quite handy. And then we have that user button on top here. You can set it up in a way that if you press it, the focus motor will go to the distance measured by the distance measure. So it's like your autofocus function, but of course autofocus is something maybe you don't want to use all the time. Maybe for emergency button, if you don't have other choice, you don't see anything, somebody run around the corner, maybe it can help. But one thing always happens in every shot, and that's a slate. So you can really focus already, be ready, slate comes in, autofocus on the slate, release, and you're back on your mark. I think that's, if you have it anyway on the camera, that's quite useful. Small gimmick. So that's the focus tracking. And then last but not least, of course, lens data for post-production. So I told you in the beginning that we calculate the lens data every frame, not only the calculated values, like 3 meters and so on, but also the raw encoder values. So if there are some VFX companies and they do their own lens distortion maps and whatever, they don't want to rely on the calculated, on the engravings on the scale. They do their own measurement, so they also get that raw encoder value. And tilt and roll. It's not the most precise, but better than nothing. So all that information is there, frame by frame, with the time code, with the image. Yeah, so with Alexa cameras, of course, it's just with the images in the metadata. Yeah, no matter if you record Arri RAW or ProRes, it's there. With the UMC4, you can synchronize the universal motor controller UMC4 with the time code with your camera. It also has an inclinometer tilt and roll sensor. It also has now the time code input. Can capture whenever you record on the camera, the thing will recognize that the camera is rolling, and at the same time, when you record a clip on the camera, it records a metadata file here with the lens name, focus iris zoom information, and so on. As a CSV file, and then you have that file, and you can use it in post-production to match. But with, of course, with inside the camera, it's a bit more convenient because it's with the images. The thing was only that it got lost many times. Not only in the film days when it completely always got lost, even in the digital times. Now, if you have a VFX heavy show and you have some VFX vendors and they give them the VFX pulse, many times we found out that the metadata is getting stripped off. And the vendors many times didn't ask, and it was just not in the workflow somehow. So we are currently taking care that even if you generate an OpenEXR file or DPX file from an Arri RAW file with third-party tools, that metadata will not get lost. And then it's really useful because you have all that information frame by frame, and you don't have to guess or look it up later. There were the 4 benefits of lens data. And one thing, there was one gap still, and I don't want to forget to mention this. I told you can do that with the encoder of the motor or of the encoder of the LDS lens. Now what happens if you want to use a manual follow focus or maybe a third-party lens control system? For that reason, we made the lens data encoder. We have it also here on the camera on the zoom scale. I think it's quite common to encode the zoom scale because you really want to know the focal length. It looks a bit like a motor. It's over here, but it is no motor because there's no motor inside. It's just the encoder. And it will give you the lens data as well. So now if you have a third party, for example, there was a Panavision show. They used a third party lens control system. Post-production really wanted lens data captured frame by frame, but they didn't get it with the third party system. They used lens data encoders. Even on another small camera with a UMC4. So you just use the UMC4 like a data capture box. It's also possible if you're a lens data nerd. And then in the end it can look like this, that you have this lens data, it's captured, being recorded with the metadata. We have the Arri RAW converter and meta extract, and then you can get that out of your images and use it again. That was the final slide of my presentation. Only the thank you slide is remaining. Do you want to say something? Do you want to say something that they hear?
No, you're going to explain the function of the system, right?
Yeah.
Y bueno, si os parece, vamos a empezar ahora a explicar un poquito el funcionamiento del sistema.
Yeah. Basically, I want to just show how to program first of all, I want to show how to program a lens file, because I think that's quite important. And it's not really difficult. So you go to the menu, go to lens data, lens programming, create a lens file. Yeah, for a lens like, can you imagine it's any kind of lens now? This particular lens we already have in the lens data archive of the camera, so I really don't have to program it, but let's imagine it's an Ingenieur zoom. So I would go to create a lens file, new lens, calibrate motors. I can skip that because I just calibrated the motors. Next thing, I select the brand. So I would say maybe a Arri see, and I can toggle through very quickly here with my thumb control. AZ for Allura zoom. I can select the focal length. Here in that case I say it's a zoom. Serial number, let's just pretend it's serial number 123. Okay. I can select if it's a metric or imperial scale. In that case it's imperial. And now I have the 3 axes here, focus, zoom and iris, and I'm going to program them. I'm gonna do some shortcuts here to save time. I could theoretically program in all the data points, but I will skip some now. So I go to focus. It tells me to set infinity, so I set the focus to infinity. Select. Now it tells me to set the close focus, and it suggests 2 feet. Now for this lens, it starts with the 4 feet, so I dial in 4 feet. Okay. Next thing is suggest 4 feet 1 inch. I just skip some, make 4.5 feet. Again, the more you make, the more precise it gets later, but if you have more than 10 data points, it should usually be enough. So next one here I've set is 5 feet. Let's say 5.5. 6. I'm a bit out of parallax, but I think this is more important to see how it works than to see my top of my head in the camera. So 7. 8. Going to 10. 15. It's very exciting, isn't it? 20. I cannot even make a joke now with those numbers. 30. 50. And of course, if you made such an effort to create that file, you can share it with your friends. If he gets a lens or she, say, hey, I did that file already, take it, use it. 200. That's a good thing if you have a file and it's not just sitting inside the handset, you know. Okay, finish. So that was the focus scale. I'm going to do the zoom. It asked me to set the wide side of the zoom. Suggest 20, but it's starting 45, so I go to 45. Now I go through. 60. I skip some to be faster. 80. The zoom is sometimes really not linear, so it's better to make more points here. 100. 120. 140. It's good in the suggestions. 60. 180. 200. And 250. Okay. Now the iris tells me to set open iris. Suggest 2. I would go to 2.6. 2.8. 4. 5.6. 8. 11, 16, and 22. Okay, now I say save to SD card. have the chance now, it automatically generated a name now, Arri AZ 45 to 250 with the serial number 123. I can edit it now if I want to give it a nickname or whatever. I don't do that now. I press save. It's saving it on the SD card. It's asking me, would you like to map another lens? If I have many, I could say yes. In this case, I say no, I'm ready. Now that file is on the SD card. As I said, we work on doing that wireless, but at the moment you now have to transfer that manually to the camera. And you put it in. You go to Lens Data Archive, Add, and again Add because you're adding the one from the SD card. Here it is. I select it. So now it's in the custom folder. Now I can use it and adding it to my favorites list. And I get my lens data on the screen. Not only on the screen, but also on this screen. So now there's still one thing. It's all fitting. So I go to 10" on my screen. I'm 10 feet on my lens. Same as for the iris. I go to, for example, 2.8. It's matching and so on. But what is not matching at the moment is a pre-marked focus ring. So to make that match, so you see here for example, I'm at 10 feet on my lens data screen and on the lens, but I'm below 10 feet on my pre-marked focus ring. That is because I didn't tell my hand unit which pre-marked focus ring I have here. It doesn't have eyes, it doesn't know it. So I have to go to the menu, pre-marked focus ring. In this case, I have the one starting at 3.5 feet. So I go to pre-marked focus ring, select the 3.5 feet one, and now it's all matching. So now really I have the same value on my pre-marked focus ring, like on the lens data screen, like on my camera. It's all identical. And the system is really, the data is generated here. And from here is captured with the images. It's shown on the monitor output. It's shown on the screen here. It's shown on the screen here. So it's all identical. Now if you want to use the lens data in post-production, because you really want to use it for VFX production maybe, it's helpful to know that I'm not having just a black box recording anything, because the AC, if he's using the lens data with a sensor, already is like a quality control. If it wouldn't be correct, he would immediately realize it and correct it. So that's the advantage of that whole system. You might realize that if you're moving very fast somehow, there seems to be a delay on the display. Your finger can move faster than the motor. That's the reason. So what you're seeing here actually on the display, that's the real position of your motor, of your lens. So even if your motor is stuck or your lens is stuck or whatever, you don't see it, you see the real position here. So it's really a consistent system. Now if we would have the UDM1 here, or a CINE tape, then we could also do the focus tracking, of course. Press that button and then the focus motor would drive to the measured value. That's basically it. It might now be that you have your lens file for that lens, you use it from time to time. Now your lens maybe gets to service and gets a bit adjusted, and you get it back and you realize there's an offset. Or it might be that you have already made a lens table for that lens in the past, and you get another lens like that, but with a different serial number. Now it might be that the scale of that lens, the numbers are the same, but the spread is a bit different because it's a different lens. Same type, but different serial number. You don't have to do everything from scratch. You can, again, put that lens file on the SD card, put it in your handset, go to lens data, lens programming, and say edit lens file. Go here. Now it will list all the lens files that are on the SD card. In my case now it's the one I just programmed. I can select it. I can go to one of those axes. I have my data points that I programmed already in here. Now if I have that new lens, or that lens that came from service, I might see there's an offset now. I'm going here to 20, and I'm not really at 20. Let's pretend it's like that. So I have 3 different ways to correct that offset. The first way would be if you have the same lens and your scale is just a bit moved like offset, you can move the whole scale. So in that case, you would press offset. While you keep it pressed, you move your lens scale and you release. Now you have just corrected the offset. It might as well be that all the numbers are a bit off. They are almost, but not really 100%. If you know my funny German English explanations. So in that case, we have the snap function. So I'm almost, so let's pretend my lens now here. I'm going to go to 30 on my lens, 30 feet. I've put such a big offset. Let me correct that a bit. Go to 30. So let's say I go now to 30 on my lens. I see here I'm a bit off, but I'm next to 30. I can press snap, and now the data point is just jumping there. So I go from point to point. Here's a bit off, but almost snap. A bit off, but almost snap. Or if it's really bad offset, I could not only snap, I could say slide. So I grab that data point, and I'm sliding it where I want it to be. So after I can do that with all axis focus I assume, correct my lens scale, adjust it, edit it, and then go back and save it. And now I might want to go, okay, right? It's the same lens, but maybe with another serial number, so I would give it another serial number. Go to override mode, for example, and it's not 1, 2, 3, but 1, 2, 4 in that case. I can save it with that new name, new serial number, that's it. So you can create lens files, you can edit lens files, you can build up your own lens data archive. You think for a rental house, it's great. A rental house has all its lenses. You can do a lens file for every lens. One time, focus puller can just check it, double check it during prep, make some small adjustments if he needs to or she, and then save some time like this.